Hello everyone, this is Telecom Christopher, and in this episode, I would like to share with you some of the knowledge on the data center design in the telecommunication field. And I have years of experiences in the data center, network design, and SDN. So in today's episode, I would like to show you the stretched layer 2 network and the virtualization. So now let's dive into the stretched layer 2 network. Before introducing you about the stretched layer 2 network, I would like to show you some of the background information on today's ever-changing telecommunication. The background, the first thing is the cloud. As you can see, the cloud is everywhere. Not only the giants such as the Google, they have the Google Cloud, but also for the telecommunication company such as the Verizon and HKT, they have their own cloud. This cloud is either for its own use, but also for the public cloud. For their own use, such as the core network cloud, which is NFVI. This is the short for the network function virtualization infrastructure, which turns into traditional hardware-based dedicated hardware into the software, which is mainly composed by the VNF, and the VNF is composed by the massive of VNFC, and often each VNFC is equal to 1 VM. And the other thing they have for the telecom operator they have is the public cloud, which is served for the public, which means the service will like the water and the electricity on demand. When you want it, you can apply and you get it. This is the future. So the basic elementary of the cloud is a virtual machine, or in other words, the virtual machine formed today's cloud. The virtual machine, virtual machine and its orchestration system. But today, I would like to focus on the virtual machine and its virtual machine network. For the virtual machine, there are several things. The first, the virtual machine shall be isolated from each other. Isolated. But also, formed, composed, collected together to realize its hardware counterpart function. So which means today's network, especially the SDN network, shall collect the virtual machine together and to realize its hardware counterpart function. And besides, the virtual machine shall be migrated freely between different data centers. This is not only because of the data center utilization, but also of the disaster recovery scheme they have. So which means that today's challenge for the network designing is massive VM, massive capacity you will cope with. So we have the ports such as 25G, 100G, or something like that. The next one is the service shall be separated with each other, shall be separated. For example, the service of the VNF1 shall be isolated with VNF2. This is a very traditional requirement. No one wants to mess with different service. And last but not least, this is the new one, is intelligent, which means on demand, service on demand.
So what did you teach, please?
Service on demand. I'm sorry, baby is coming. Service on demand, which is the requirement of SDN. Either you have the SDN in the data center, normally such as Huawei's Agile controller and Cisco's ACI solutions. Besides, you will see the SDN controller in the WAN network, which we call SDN WAN. So, traditionally, how to connect with the different data center? This interconnection. We have the technology such as VPLS. VPLS is born to collect the different data center, and it is fully used of the powerful MPLS technology. But the VPLS is just simulate the entire network into a switch. It's a switch. What does switch mean? Switch means is MAC reading only, very high efficient, but it's not that clever. VPLS simulate the entire network into a switch, and meanwhile, it inherits the drawbacks of switch, such as broadcasting for the bomb traffic. How to resolve those traditional problems? The best way is let the control plane seems even more status than before. So this is the way to resolve the problem we encountered traditionally. To make a clever brain for the network. So which means, as you can see in today's network, we have the SDN controller or orchestrator acting as the brain. And then we have the traditional switching plane, such as the VPLS, that is out of date, frankly speaking. It will be gradually replaced by the new technology such as the SRv6 or something like that. VPLS, but today we have the even more powerful ones such as the VXLAN in data center and SRv6 for the WAN or MPLS, SR, the two kinds of things. Okay. So all in all, today we will focus on what is the stretched layer 2 network. If the one virtual machine wants to migrate to other disk, to other place, what they will do, the first thing they will have is keep the same IP and MAC address. For example, imagine one scenario: you download one movie from a link, for example, such as FTP 192, 168, 10.10, and suddenly the IP address has been changed. You definitely lose that collection. And then the other thing is, not only the virtual machine shall be migrate from one place to the other, but it must be functioning as before. Or in other words, VM cannot notify or sense the migration. How to do that is the gateway. You either connect with the legacy gateway, or shift over from legacy to new gateway. To this very few point, you will have the technology when you do the migration, for example, as VRP. As you can see, I insert one here. This one is we called the legacy, and this one is the new place. And besides, you have the virtual machine like this. This one is a clever virtual machine. VM. It moves from here to here. How do we ensure the service without any interruption? Mostly we have the way is collect this one, both, collect both of them via VRP. But when you do that, but the post-sale guy told me that VRP normally is not working. The service will interrupt for a few minutes because of the restriction from the hardware. And with in order to have the high availability, we also have the one which is Anycast gateway, which means all the switches here share the same IP address. With this collection field, the VM cannot sense the IP and the MAC address change. How to do that? For example, in the data center, SDN-based data center, we have the BGP EVPN. The BGP EVPN will synchronize all of the switches with the same IP and MAC address. Okay. So let's move on to the next part, which is about the virtualization. Sometimes the people is confused with the virtualization, and the stretched layer 2 network. Oh, sorry. Another thing is the stretched. Because previously, as we all know, that the VLAN is 4096 subnet. This is definitely not enough. Because for the cloud-based data center, we have even millions of virtual machines. This cannot cope with the scalability issue, and so we have the virtual extended LAN. Normally, we have around 16 million subnet, and you can see based on the VNI, and you can calculate that. So this is called the stretched network. The stretched network, which means the VXLAN. The VXLAN will simulate both the layer 2 or the layer 3 VPN. Each of the VXLAN is identified by the VNI, and each VNI is corresponding to one bridge domain, that is bridge domain one VNI is corresponding to one bridge domain, which is stretched layer 2 network. But the virtual machine residing server can either have same address, which is layer 2, or different IP address in layer 3. So the VXLAN, just frankly speaking, the VXLAN is the same as the VPLS, and this very few moment. You can see the VXLAN, the GRE, and VPLS are the same because they are working as the forwarding plane. And the principle is the same: digging a hole, digging a tunnel to pass the underlay network. But VXLAN is more advanced because the VXLAN has a very big overhead. He will communicate with the SDN controller, and he will also pass even more status to its brain. So the SDN controller can sense even more status information and to make the best and optimized decision based on the VXLAN information. Okay, let's go to the other topic, which is the virtualization. The virtualization is either simulate one switches into more, such as the technology virtual system, or more into one. Traditionally we have technologies such as Huawei CSS, Cisco, VP is not VPC, VSS or something like that. But this technology have the drawback because they have a very strong coupling of its management plane, control plane, and data plane. There's an obvious drawback when you do the upgrading. If one failed, the entire system will be failed. And now we have a more advanced one, which is called MC lag, which is multi-chassis link aggregation group. And often, how to form an MC lag, they have different ways. The first, to determine who will join, which switches will form an MC lag. Then, who is boss, who is master, who is slave. This who is master, who is slave is not only focused on the switch itself, but also on the ports, because MC lag is based on the ports. And then the third one is the habit, which is to detect, to prevent the dual master scenario happen. So I think those are the major steps to form the MC lag. When one failed, it will change automatically changing to the other one. This is the virtualization. So the stretch and the virtualization is totally the different things. Okay, this is today's presentation. If you have any recommendations, just leave a message to me. Thank you very much.